Hello students, in this video we are going to solve the problems of exercise 3.3 of the chapter trigonometric function of NCERT textbook of mathematics class 11. Okay, so now before we solve the problems of this exercise we must know this formula. I'm scrolling down the page. Okay, you may take a screenshot. Okay, so these are very important formula. Okay, and these are addition and subtraction formula. So take a screenshot or you may pause the video to note down. And these are transformation formula. Okay, these are transformation formula. Take a screenshot here as well. Then these are the formulae related to the trigonometric ratios of multiples and submultiple angles. And please note down the formula or take a screenshot of those also. Okay, if you know all those formulae, then only you can solve the problems of this exercise 3.3 of the chapter 3, that is trigonometric function. Okay, now let me show you how to solve the problems of this exercise. Okay, so this is the first question, so let me show you how to solve this. So here we need to prove this left hand side, which is sine square pi by 6 plus cos square pi by 3 minus tan square pi by 4 is equal to minus half. So let me take the left hand side first. So left hand side is sine square pi by 6 plus cos square pi by 3 minus tan square pi by 4. Okay, now we know the value of sine pi by 6. Okay, pi by 6 means 30 degree. So sine 30 is nothing but half. So it must be half square. Okay, because there is sine square. Then cos pi by 3 means cos 60, which is again half. Okay, as there is a square, so it must be half square. Then tan square pi by 4. Pi by 4, 10 pi by 4 means tan 45 degree, that's equal to 1. So as there is tan square, so it must be 1 square. Okay, so here you see, so square of half is 1 by 4. This is also 1 by 4. Then 1 square is 1. So then just simple calculation, which is gonna be equal to minus 2 by 4, that's equal to minus half. So this is the right hand side and it's proved. Okay, so that is what we need to do. Okay, that's how we can solve the first one. So now let me show you the second one, question number 2. Okay, so let me take the left hand side of question number 2 first again. Left hand side, 2 sine square pi by 6 plus cosec square 7 pi by 6 into cos square pi by 3. Okay, so this is the left hand side. Okay, now sine pi by 6. Pi by 6 means sine 30 half, so it must be 1 by 2 square. Then cosec 7 pi by 6. Cosec square 7 pi by 6 can be written as pi plus pi by 6. So here we are going to apply Astc rule. Okay, into cos square pi by 3. So pi by 3 is 60 degrees. So cos of 60 degree. So cos of 60 degree is half. We know that half. So it must be again half square. Half square. Okay. So now let us apply the Astc rule. Okay. Here you see Astc. That means here all positive, all trigonometric values of all trigonometric ratios are positive. Here sine and cosec, sine and cosec, sine and its reciprocal is cosec, so it is positive in the second quadrant. okay, and here tan and cot positive, okay. Other than tan and cot, in the third quadrant all trigonometric ratios are negative, okay. So here you see, from this line to here, this is pi, that is 180 degree, isn't it? And pi plus something that must lie in the third quadrant, okay. So here this is 2 into 1 by 4. You can see in the third quadrant, other than tan and cot, values of other trigonometric ratios are negative. So here value of this trigonometric ratio must be also negative, okay. So here we will get minus cosec, as pi is even multiple of 90, so cosec remains cosec, so cosec pi by 6. Here you see this is square, that's why we can write like this, whole square into 1 by 4, okay. 2 to the 4 here. So now 1 by 2, on squaring this minus will be on squaring this minus sign will be plus, so it's become plus cosec pi by 6. Cosec pi by 6 means it is cosec 30 degree, okay, cosec 30 degree, and cosec 30 degree is 2, okay, it is 2, and 2 square, so that's why it must be 4. You can write that instead of writing 2 square you can write 4, okay, or just keep it 2 square, okay. So 1 by 4, so 2 square is 4, so that's why it will be cancelled with this. Then we will get half plus 1, and that's going to be equal to, after taking LCM, we will get 1 plus 2 by 2, sorry, it must be 2, that is equal to 3 by 2, and this is the right hand side. So this is the right hand side. So good, that's how we can solve this, okay. So question number 3 and question number 4, these are similar type of questions, so I hope you can solve these two, okay. So now let's move on to question number 5, okay. Now let me show you how to solve question number 5, okay. So here first one is sine 75 degree, okay. So sine 75, it can be written as sine of angle 45 plus 30 degree, okay. So it can be written like this. Now here we are going to apply this formula, sine A plus B is equal to sine A cos B plus cos A sine B, okay. So here we are going to use this formula, okay. Now consider this one as A, this one as B, okay. So then if you apply this formula, then you will get sine 45 cos 30 plus cos 45 sine 30, okay. Now put the values of these ratios. Sine 45, that's going to be 1 by root 2, then cos 30 root 3 by 2 plus cos 45 1 by root 2, then again sine 30 is half, okay, sine 30 half. Now let me simplify this to, so here root 3 by 2 root 2, and here also 1 by 2 root 2, so that's going to be equal to 2 root 2, here root 3 plus 1, okay. So this is the answer, okay. Similarly you can solve the next one also. Here you see number 2. Now next one is 10 of 15 degree, okay, 10 15 degree. So this can be expressed as 10 45 minus 30 degree, okay. So here we are going to apply this identity 10 A minus B. 10a minus b. That's equal to 10a minus 10b by 1 plus 10a into 10b. Okay, now we are going to apply this identity. Okay, now here you see, consider a is 45 and b is 30. Okay, now apply this identity. Okay, doing so we will get 1045 minus 1030 by 1 plus 1045 into 1030. Okay, 1030. So now let us put the values of 1045 and 1030. Okay, then if we put the value of 1045 and 1030, then what we will get? Okay, so 1045 is 1, 1030 is 1 by root 3, 1 plus 1045 is again 1, 1030 is 1 by root 3. Okay, now this is equal to 1 minus 1 by root 3 by 1 plus 1 by root 3. Okay, so let us rationalize the denominator. Okay, first let us multiply both the numerator and denominator by root 3. Okay, let us multiply root 3 here, then you will get root 3 minus 1, then root 3 plus 1. Okay, so now here you see, in order to rationalize the denominator, so here you see denominator is root 3 plus 1. Let us multiply both the numerator and denominator by root 3 minus 1. Okay, and doing so we will get here root 3 minus 1 whole square by root 3 plus 1 into root 3 minus 1. Okay, that's equal to, so here we are going to apply a minus b whole square formula. That's it gives 3 minus 2 root 3 plus 1, and here we are going to apply a plus b into a minus b formula. That's a square, that is root 3 square, minus b square, that is 1 square. Okay, and which is equal to 4 minus 2 root 3 and 3 minus 1. Okay, 3 minus 1, then what will be the answer? Four minus two root 3, here 3 minus 1 2. Okay, that's equal to 2 minus root 3. So this is our answer of the second question of question number 5. Okay, so now let's solve question number 6. Okay, we need to prove this. Okay, in order to prove this relation, we are going to take the left hand side first. Okay, so here the left hand side is cos pi by 4 minus x, cos pi by 4 minus y, minus sin pi by 4 minus x, sin pi by 4 minus y. Okay, this is the left hand side. Okay, now you see here what we are going to do. Here we are going to apply two identities. Okay, one identity in this part. Okay, for this part, and another for this part. Okay, and what are those identities that we are going to apply, or formulae we are going to apply? do the 2 cos A cos B is equal to cos A plus B plus cos A minus B. Okay, plus cos A minus B. So we are going to apply this. So here you see, in order to apply this, consider A as this part and B as this. Okay, so we can consider that this part is in this form. Okay, so this is 2 into cos A cos B. So you can write this 2 on the other side as half. Okay, this can be written as cos A cos B is equal to half of cos A plus B plus cos A minus B. Now consider this one as A and this one as B. Okay, then if you apply this formula, then you will get half of cos A plus B. Okay, cos of A plus B. So here pi by 4 minus x plus pi by 4 minus y. Okay, then plus cos A minus B. Okay, plus cos A minus B. Cos A minus B will be pi by 4 minus x minus pi by 4, and again minus, this is also minus, so it will be plus y. Okay, then in the next part, in this part, we have to apply another identity. Okay, so let me show you that one. For this part, we are going to apply minus 2 sine A sine B, that's going to be equal to cos A plus B minus cos A minus B, and it implies sine A sine B is equal to half of, minus, or you can consider like this, minus sine A sine B. You can consider this one as minus sine A sine B. Okay, this is A and this is B. Okay, so we have considered this one as minus sine A sine B. Okay, so first angle is A and this is B. Okay, then here we will get sine, cos of A plus B minus cos of A minus B. Okay, so then consider this one as A and this angle as B. Okay, this is as A, this is as B. We will get minus, this minus is here, we have considered as minus sine A sine B. Okay, so then it implies plus, this part is equal to plus half cos A plus B, that means pi by 4 minus x plus pi by 4 minus y, then minus cos A minus B, that will be equal to pi by 4 minus x minus pi by 4 and minus plus y. Okay, so that's how we can solve. Okay, so let me erase this part. Okay, now let me clean this part also. Okay, so let me write this one here. Okay, so Now let us simplify. So half is equal to cos pi by 4 plus pi by 4, that's going to be equal to pi by 2. That will be equal to pi by 2 and minus x minus y. Okay, then so here also pi by 4 minus pi by 4 cancel, then we will get minus x plus y. That means you can write cos y minus x, then plus so we are taking these two half common. Okay, half and half. Okay, then we will get here plus cos of again pi by 4, that is pi by 2, then again minus x minus y, minus x minus y. Here again it will be here pi by 4 minus pi by 4 cancel, minus x plus y. That means you can write minus cos y minus x. Okay, so bracket close. Okay, so hope you have understood up to this point. So now you see these two cancel each other. Okay, these two cancels each other. Now this is equal to half. So these two are same terms, and adding these two we will get 2 cos of pi by 2. From these two we can take minus common, minus x plus y. Okay, so we will get this result, and here 2 to cancel. Now apply Astc rule. Okay, here you see pi by 2 means 90, or you can consider 19 into 1, and 90 into 1 is odd, that's why cos will be converted to sine. Okay, sine, and 90 minus something is first quadrant, lies this angle must be lying in the first quadrant, so where it must be positive. All ratios are positive in that in the first quadrant, so we will get sine x plus y. So this is the right hand side, hence proved. Okay, so let me minimize this. So this is your complete solution of question number 6. Now let me show you how to solve question number 7. Okay, so here we are going to apply two formulae. Okay, and those are tan a plus b is equal to tan a plus tan b by 1 minus tan a into tan b. Okay, and next one is tan a minus b, which is equal to tan a minus tan b by 1 plus tan a into tan b. Okay, so in order to solve this, let us take the left hand side first. Left hand side is tan pi by 4 plus x. Here we are going to apply this formula, tan a plus b, and the denominator is tan pi by 4 minus x, and here we are going to apply this formula, tan a minus b. Okay, so let's apply. If you apply here tan a plus b, then you will get tan pi by 4 plus tan x 1 minus tan pi by 4 into tan x. Okay, then if you apply here tan a minus b in the denominator, then you will get tan pi by 4 minus tan x by 1 plus 10 pi by 4 into 10x. Okay, so here this is equal to this part, and this denominator is equal to this one. Okay, so hope you have understood this. So now let us simplify here. Okay, so pi by 4 is nothing but 45 degrees. Okay, and 10 45 is equal to 1. Okay, so we know that. Let's put the value here. So we will get here 1 plus 10x by 1 minus 10x. Similarly, in the denominator we will get 1 minus 10x by 1 plus 10x. Okay, 1 plus 10x. So let me write the remaining part on this side, on the right hand side. Okay, so let me clean it. Okay, so now this is equal to here you see that's gonna be equal to 1 plus 10x by 1 minus 10x into 1 plus 10x by 1 minus 10x. Yes, so now if you multiply these two, then you will get 1 plus 10x by 1 minus 10x whole square. So that is the right hand side. Okay, hence it is proved. So that's how we can solve question number 7. Okay, so now you can pause the video to note it, and let me show you how to solve question number 8. Okay, so let me show you how to solve it. So now let me solve question number 8. Here it is. Again, let us take the left hand side. The left hand side is cos pi plus x into cos of minus x, and divided by sine pi minus x into cos pi by 2 plus x. Okay, so here you see cos pi plus x. That means here you see if it is 0, then this is pi plus x, pi plus x must be here. This is first quadrant, second quadrant, third quadrant. In the third quadrant, tan and cot positive only. Other than these two ratios, other ratios are negative. Okay, so and again one more thing, that pi is even multiple of 90, 2 into 90. Okay, so that's why cos pi by x must be minus cos x. Okay, so minus cos x, and cos of minus x, if this angle, now look at the figure here, if this angle is x, then minus x will be this one. That means in the fourth quadrant cos is positive, so we can write cos of minus x is cos x simply. Okay, then again let me clean this. Sine pi minus x. Okay, what will be the value of sine pi minus x? Sine pi minus x. So let me do the excess again. So here you see it is 0 from here to there. It is pi. Okay, sorry. So this is pi, and pi minus x, so it's going back. That's why this angle will be pi minus x. So in the second quadrant. In the second quadrant, sign remains positive. Okay, and pi is even multiple of 92 into 90. That's why sign remains signs. Okay, so it must be sin x. So we can write sin pi minus x is equal to sin x, and cos pi by 2x, cos pi by 2 plus x, cos pi by 2 plus x. Okay, so what will be its value? So let us again apply the Astc rule here. Here you see, from here to there, this angle is pi by 2, that is 90 degree, and plus something, it must lie in the second quadrant where sine is positive but not cos, but here it is cos. Okay, and pi by 2 means 90 into 1, odd multiple of 90. So that's why cos changes to sine. Okay, sine x, and it must be negative, though here we have got sine, it must be negative because initially it was cos. Okay, so we have got minus sine x. Okay, so we have got minus sine x. Now you see, here we have got both the numerator and denominator negative, so minus minus cancel. Okay, then it's very simple simplification. Cos x cos square x, and sin x sin square x, and cos by sin is cot, so we can write cos square by sin square x is equal to cot square x, which is the right hand side. That's how we can prove this. Okay, this is question number 8. Okay, so hope you have understood this. Now let me show you how to solve question number 9. This is question number 9 and it's very simple. Okay, so in order to solve it, let me write the left hand side first. Okay, so what is the left hand side here? This is cos 3 pi by 2 plus x into cos 2 pi plus x in bracket cot 3 pi by 2 minus x plus cot 2 pi plus x. Okay, so this is the left hand side. So here we are going to apply the Astc rule. Okay, so this is all sine tan cos. Okay, so now this term is cos 3 pi by 2 plus x. So here 3 pi by 2, this is 1 pi by 2, then 2 pi by 2, 3 pi by 2, this is 3 pi by 2. Okay, then plus x means it must be lying in the fourth quadrant where cos is already positive, and 3 pi by 2, 3 into pi by 2 means odd multiple of 90. Okay, odd multiple of 90. Okay, pi by 2 is 90 and 3 into 90, so odd multiple of 90. So that's why this cos becomes sine. Okay, and in the fourth quadrant as cos positive, so it will be positive sin x, though here it is sine, initially it was cos, so you cannot put negative here. Okay, so now next one is cos 2 pi plus x. So how to obtain its value? So again we are going to apply Astc rule. So this is 1 pi and this is 2 pi. This is 2 pi. Okay, 2 pi plus x means, so it must be lying in the first quadrant where all trigonometric ratios are positive, and 2 pi, this 2 pi means 4 into 90, which is again even multiple of 90, so cos remains cos, so it will be cos x. Okay, then cot of 3 pi by 2 minus x, this term cot of 3 pi by 2 minus x, 3 pi by 2, so this is 3 pi by 2 here you can see, and minus x, so it must be lying in the third quadrant. Okay, let me clean this first. So here you see from here to there it is 3 pi by 2. Okay, then minus x, subtract minus subtract x, So in the third quadrant, cot positive and tan also positive, and here you see as it is odd multiple of 90, so it must be converted to 10x. Okay, then again here it is, the last term is cot 2 pi plus x. Okay, so this is 2 pi here. Let me clean it again. So this is pi, and here is 2 pi. 2 pi plus x means it must be lying in the first quadrant where all trigonometric ratios are positive, and 2 pi is even multiple of 90, so that's why cot remains cot x. Okay, so now sin x into cos x. So we know 10x is equal to sin x by cos x, and cot x is equal to cos x by sin x. Okay, so if you multiply these two, then what you will get? Then we will get, so if you multiply this one with this, then cos will be cancelled. We are going to have sin square x. Okay, then again if you multiply this term with the next term here within bracket, then here sin x will be cancelled, then we will have cos square x. Okay, so hope you have understood this. So then you know sin square x plus cos square x is equal to 1. Okay, that is the right hand side. So that's how we can prove. Okay, this is question number 9. So now let me show you question number 10. Now let me show you how to solve question number 10. Okay, it's very simple. So let us write the left hand side again. Left hand side, this is equal to here sin n plus 1 into x. So let me write this more clearly. N plus 1 into x sin n plus 2 into x plus cos n plus 1 into x cos n plus 2 into x. Now consider this angle as A and this angle as B. Okay, so here also this is A and this is B, suppose. Okay, so we know that cos A minus B is equal to sin A sin B plus cos A cos B. Okay, now if you observe this left hand side, it is in this form. Okay, it is in this form. Okay, so assuming this one as angle A, this one as angle B, A and B, we can apply this identity here. Okay, if you apply this identity here, then you will get, so what you gonna have, cos A minus B, that is n plus 1 into x minus n plus 2 into x. This is cos A minus B. Okay, so here we have applied this identity. Okay, now cos of n plus 1 minus n plus minus 2 and take x common. Okay, so here n gone, so we have cos 1 minus 2, that's going to be minus 1 into x minus x, cos of minus x. And here you see again, so this is the first quadrant and this is suppose angle x, then this angle will be minus x, and in the fourth quadrant cos is positive, that's why cos of minus x will be cos x again. Okay, this is cos x and this is the right hand side. Okay, that's how we can prove. Okay, so it's very simple. Hope you have understood this. Now let's move on to the next question. Now let me show you how to solve question number 11. Okay, So this is question number 11. So again we are going to write the left hand side first. Left hand side, that is equal to cos of 3 pi by 4 plus x minus cos of 3 pi by 4 minus x. Okay, this is the left hand side. So here we are going to apply the identity or formula, this one, minus 2 sine a sine b, which is equal to cos of a plus b minus cos a minus b. So here we are going to use this formula. Okay, so how to use this formula? Here you can see, if you compare this result with this part, okay, then you can consider here this one is a plus b and this is a minus b. This is cos of a plus b, this is cos of a minus b. So here a means, so you can consider a means 3 pi by 4 and b means x. Okay, you can consider this. So the result gonna be equal to, so its result will be let me clean this first. So that's gonna be equal to minus 2 sine a means 3 pi by 4 and sine b, that is x. Okay, so just apply this identity, it's very simple. Okay, then sine 3 pi by 4. Okay, sine 3 pi by 4 means here you can see, you can consider sine 3 pi by 4 as 4 pi minus pi by 4. Okay, so then you can consider this one as sine pi minus pi by 4. Okay, so we can write sine 3 pi by 4 as pi minus pi by 4. Okay, then sin x remains sin x. Okay, so now we are going to apply the Astc rule. Okay, Astc rule. So what was that? So here you see, so all sine, tan, cos. Okay, now pi means this is pi, this angle is pi, minus something that must be lying in the second quadrant, minus pi by 4, isn't it? Pi minus pi by 4. So this angle will be pi minus pi by 4 after subtracting after subtracting pi by 4. Okay, from pi we will get pi minus pi by 4. This is, so here you see it is lying in the second quadrant where sine is positive, and pi is even multiple of 90, 290, 180, 180 means pi. Okay, so that's why sine remains sine, and as it is this angle in the second quadrant, so sine remains positive, so minus 2 into sine pi by 4 into sine x. Okay, so now what is the value of sine pi by 4? Sine pi by 4 means sine 45, that is 1 by root 2 sine x. So now cancel 2 by root 2, then you will get root 2 here. So our result is minus root 2 sine x. Okay, and this is the right hand side, this is the right hand side, hence proved. Okay, that's how we can prove this. So this is the solution of question number 11. Okay, now let me show you how to solve question number 12 and 13. Okay, so in order to solve these two problems, we are going to use this identity. Here you see, for question number 12 we need to use sine square a minus sine square b, that's equal to sine a plus b into sine a minus b. So we are going to use this formula, okay, in question number 12. So again let me take the left hand side first. that is sine square 6x minus sine square 4x. So let me clean it. Okay, here you see, consider 6x as A and 4x as B, then use this identity. So using this we will get sine A plus B here, that is 6x plus 4x, sine A minus B, that is 6x minus 4x, sine 6x minus 4x. Okay, now it is sine 10x and sine twice x. So this is the right hand side. You can rearrange this like this, 10x. So this is the right hand side, hence it is proved. Okay, so that's how we can prove this. Okay, so pause the video and note it. Now let me solve the question number 13. Okay, so here cos square twice x minus cos square 6x is equal to sine 4x sine 8x. So here also here you see, if sine square A minus sine square B is equal to sine A plus B into sine A minus B, and if you write sine A plus B or B plus A, and instead of A minus B if you write sine B minus A, then it will be equal to cos square A minus cos square B. Okay, now remember this one also as identity. Okay, so we are going to use this here in question number 13. Okay, so let me use it here. So now take the left hand side of question number 13. So what is the left hand side? Cos square twice x minus cos square 6x. Okay, now consider this one as twice x and this one as twice x as A and 6x as B. Now apply this identity. So this left hand side is in this form, so we can write in this form using this formula. Okay, so here we will get sine B plus A, that is 6x plus twice x, then sine B minus A, that is 6x minus twice x. Okay, that's gonna be equal to sine 8x, and here it is sine 4x. Okay, so you can rearrange it again, sine 4x and sine 8x. Okay, this is the right hand side, hence proved. Okay, so hope you have got this. Now let me show you how to solve question number 14. Okay, so again we are going to write the left hand side first. Okay, question number 14, left hand side. So sine twice x plus 2 sine 4x plus sine 6x. Okay, now write sine 6x with sine twice x. Okay, then sine 6x plus sine twice x plus 2 sine 4x. Okay, so here in this part sine 6x plus sine twice x, here we are going to apply this identity. Sine C plus sine D, that's equal to 2 sine C plus D by 2 cos C minus D by 2. So let us use this identity here. Using this identity we will get 2 sine 6 plus twice x by 2. We have considered 6x as C and twice x as D. Okay, then cos C minus D, that is 6x minus twice x by 2. Okay, plus 2 sine of 4x. Okay, so here 6x plus twice x is 8x divided by 2, that's going to be 4x, and this is going to be twice x. Okay, 6 minus 2x, 6x minus 2x, 4x divided by 2 is 2x. Okay, so now 2 sine 4x. Now let us take this 4x as common. Not only 4x, sine 4x, 2 sine 4x as common. Okay, on taking 2 sine 4x common, we will get cos twice x plus 1. Okay, we will get this one. Now 2 sine 4x, we know that cos twice x, so we have got this identity or formula already. What was the identity here? Cos twice x is equal to 2 cos square x minus 1. Okay, so that's why we can write cos twice x plus 1 is equal to 2 cos square x. Now use this identity here. Okay, and doing so we will get 2 cos square x. Okay, we will get this. So now 2 to the 4, so we will get 4 cos square x sine 4x. We have rearranged this, and this is the right hand side, hence proof. Okay, that's how we can solve question number 14. Now let me show you how to solve question number 15. Okay, so again we are going to write the left hand side first. Okay, question number 15, that is cot 4x sine 5x plus sine thrice x. Okay, so here in this part, within bracket, we are going to use this identity again, sine c plus sine d. That's equal to 2 sine c plus d by 2 cos c minus d by 2. Okay, let us use it here. Okay, so cot 4x into 2 sine 5x plus thrice x divided by 2 cos 5x minus thrice x divided by 2. Okay, sine 5x plus thrice x by 2, that's equal to 8x by 2, that is 4x, so it will be sine 4x, and here cos 5x minus thrice x by 2, that's going to be twice x by 2, that is cos x. Okay, that's cos x. Okay, now here you see cot 4x can be written as cos 4x divided by sine 4x. Okay, into 2 sine 4x into cos x. Okay, here sine 4x gone, so we got here 2 cos 4x and cos x. Okay, so now what we're going to do, here you see in the right hand side, as we are going to obtain we need to obtain cot x. So cot x is equal to cos x by sin x. So that's why we are going to write here we can write cos x by sin x into 2 cos 4x into sin x again. Okay, if you cancel sin x, then again 2 cos 4x and cos x, you will get this. Okay, hope you have understood this step. Okay, so we have done this simplification in order to obtain the cot x on the right hand side of this question number 15. Okay, so hope you have understood this. So let me do the next part on the other side here. Now as you can see, as we have got here cos x by sin x, so which is equal to which is equal to cot x, then 2 cos 4x, this one, cos 4x. Cos 4x can be written as cos 5x plus thrice x divided by 2. 5x plus thrice x, 8 divided by 2 is 4. So 8x by 4 is 2, that is 4x. So where I have written this 5 plus 3 by 2, because here we are going to obtain 5x minus thrice x in the right hand side, that's why. Then sin x can be written as 5x minus thrice x, that is 2x divided by 2, again x. Okay, so here we have got cot x, and again we are going to apply here sin c minus sin d formula. Sin c minus sin d, that is equal to 2 cos c minus d by 2 cos c plus d by 2 into sin c minus d by 2. Okay, now you see this part and this part are in the same form, so that's why we can write this result in this form. Okay, if you write that, then you will get sin 5x, you can consider now 5x as c and thrice x as d. Okay, minus sin d, that is thrice x. Okay, sorry, thrice x. So this is the right hand side, this is our right hand side, hence proved. That's how we can prove this. Okay, hope you have understood this. So it's very simple, not so hard. Okay, so that's how we can solve it. Now let me show you how to solve question number 16. Okay, so question number 16. So what is the left hand side here? Cos 9x minus cos 5x by sin 17x sin thrice x. Okay, now apply here cos c, you can apply here cos c minus cos d formula, that's equal to minus 2 sin c plus d by 2 sin c minus d by 2. You can use this here, and here for the denominator you can use sin c minus sin d, that's equal to 2 cos c plus d by 2 sin c minus d by 2. Let us use these two formula. Okay, so if you use these two, then in the numerator you will get here. So let me write it here. So minus 2 sin, that is 9x plus 5x by 2, and sin 9x minus 5x by 2, and here in the denominator you will get 2 cos 17x plus thrice x by 2, then sin 17x minus thrice x by 2. To cancel here. Now here you see it's become sin 9x plus 5x, that will be 14 divided by 2, 7x, then 9x minus 5x, that will be 4x divided by 2, twice x. So here it will be sin twice x. So here we will get cos 17 minus 3, 20 divided by 2, so cos 10x, there will be minus cos 10x, and sin 17 minus 3, that's equal to sin 14x by 2, that is sin 7x. Okay, sin 7x. So here sin 7x gone, so we have got right hand side, that is minus sin twice x divided by cos 10x. So that is the right hand side. So hope you have understood this. So this is the right hand side, hence proved. Okay, now let me show you how to solve question number 17. Okay, so let us write the right hand side first, left hand side, that is sin 5x plus sin thrice x by cos 5x plus cos thrice x is equal to, so we have to show tan 4x. Okay, so here also again we are going to use sin c plus sin d formula, that's equal to 2 sin c plus d by 2 sin c minus d by 2, and in the denominator we are going to use cos c plus cos d formula, that's equal to 2 cos c plus d by 2 cos c minus d by 2. We are going to use these two. Okay, so let me use these two. So for this we are going to have 2 sin 5x plus thrice x divided by 2, then cos 5x minus thrice x divided by 2, and for the denominator we are going to have 2 cos 5x plus thrice x divided by 2 cos 5x minus thrice x divided by 2. Here these two are same, so we can cancel directly here. So now you see 2 also cancel, not 2 should not be written here. Okay, so now sin 5x plus thrice x divided by 2, that means 5x plus thrice x 8x by 2 4x, so sin 4x. Here we will get cos 4x, and that's going to be equal to tan 4x, because sin by cos is tan, isn't it? So this is the right hand side, hence it is proved. Okay, it's very simple. So